Right, please welcome Lou again, and he will tell you some. Actually, I have no idea what they're like.
Hey guys, to be honest, me neither, so let's see how it goes. Yeah, I just put my name just in case you forgot, but Danny said it, so let's get started. I'm gonna be talking to you in the last lesson about how to optimize your apps, because you spend a lot of time working on this, and if you really care about releasing this to production, there are like some things that you should know. Optimization is like a really huge topic, and it won't fit in a 1 hour lesson. It's mostly like a 10 years lesson, so I'm just gonna try to cover what is like the most relevant stuff, and then you will take it from there. So there are some key factors that you should care about when dealing with performance. One is fast first meaningful pain, but we already covered this on the last lesson, so no need to talk about it. Server response, we already talked about it. You will have to cache your responses when you're using server-side rendering, and if you're not, then just use a CDN. Images is like a huge topic, so we won't be able to cover that. It's like a huge topic on its own, so you will probably have to research on that besides this. And also CSS is a huge important bottleneck in terms of performance, but we won't have time to cover this, and we didn't even cover CSS in this course, so it doesn't matter. But just know that style components will probably reduce all of these worries. Now, what we're gonna cover is CPU and memory usage. This is what we're gonna focus here. And there are two main topics inside this. The first one is performance related to the initial load of the app. This is called TTI, or time to interactive. It means as soon as somebody goes to the browser, hits the URL, it's how long it takes for you from that opening the browser and interacting with your website. The first meaningful paint doesn't count for this. It's just when your app is like completely usable. And the other part will be the life cycle of your app. So this means when you're using the app for a long time after the time to interactive. So the beginning and just the rest. And there are two different types of optimizations that you could do based on which ones is your goal. So let's talk first about time to interactive, or TTI. This is very critical. As I mentioned on previous lesson, for the first meaningful pain, there are also statistics that back up that the faster this is, the better your users will perceive the app usage, and it will in turn convert into sales or conversions. So there is this tool, I don't know, have you ever heard about Lighthouse? Okay, cool, nice. Okay, Lighthouse is a tool provided by, created by the Chrome team. It's actually embedded on the actual Chrome developer tools. This is recently. I'm gonna show it in a demo by the end of the presentation. But just so you know, this thing is gonna help us to measure like some metrics about performance, and mostly for time to interactive. So it's just going to work for the first part of performance that we're gonna care. So there are like a lot of metrics here. The only one we're gonna care is performance. So let's say the one that, the second one here. So let's see how we can start improving. I mentioned Lighthouse because when we're talking about performance, There's like a saying that you should usually not care about this in the beginning. You should just build your app and then test if everything is good. If there is some performance issues, then you go and fix it. And this is the tool that's going to help us to realize that every time we change something, is it going to help or is it going to do nothing in our goals for performance on TTI. Even saying that there is also some tricks that you can use even from the beginning of when you're creating your web app, because it's gonna help like pretty much in every situation, but just don't get crazy with performance yet. It's there is this tool called Webpack Bundle Analyzer. Once you set up this on your project, and you could see what are all the dependencies that your project is using, all the JavaScript, the local files that you're using, and it kind of works like this. The bigger it is, the name of the files, it means that that library is bigger than the rest. And you can hover over these things and it will show you how many kilobytes it is. And this way you can have like a better idea of what's going on with your application, because sometimes you're just importing and you don't know that some library is also important, like 20 libraries more, and you need to be aware of these things if you really care about performance. So let's talk a little bit about Jess parsing. JavaScript, as you know, is a parse language or a scripting language or compile interpret language, as opposed to like C or C#, all these things. So it goes through a very specific flow that is something like this. Your browser, like Chrome, has V8, which is the JavaScript engine, and it's gonna, once you download all the JavaScript, it's gonna read everything, and it's gonna create like a basic interpretation in machine code for this. And this is gonna be like the slow version of JavaScript. This is the first thing you get. And once you start using the application, is gonna check, okay, these functions are being run a lot. So the browser goes and check, okay, I'm gonna take this click handler that is being run like many times. I'm gonna analyze it a bit more, and then I'm gonna improve and create like an improved version of the machine code. This is called just-in-time compilation, or JIT for short. This is just something to keep aware. That's why sometimes, even though functions are slower than for loops, the browser can optimize it on the long run. It's easier for the browser to optimize functions than for loops. So the important thing is that the more JavaScript you have on your application, the more time and resources are gonna be spent by the browser on interpreting this and parsing this and in doing a lot of optimizations. And sometimes you're not even using this JavaScript. It's just there because it's part of other section of your application that your user is not actively interacting at this moment. So always consider, if you ever heard about gzip, it's something that you do on your files on the server to make them smaller when you send them over the network. The thing is that we usually tend to focus when we see a library, oh, it's this 5 kilobytes, it's quite small. That's okay for networking performance, but it's not the real thing that your V8 has to deal with. V8 has to deal with the actual ungzip file. So if it is 5 kilobytes, it's probably 200 kilobytes. If it is 200 kilobytes gzip, it's probably like a megabyte. So that's what you need to, this is the stats that you need to care about when thinking about performance in terms of how big are your files. And also every file that is parsed is gonna take some certain amount of memory. That's just the way it is. So the whole point is avoid big libraries. sometimes you might not know that you have like a Godzilla hidden in your library, for example, Mom and Jess. So there's this tool called Phobia. It's not like a tool, it's like a website. You go to the website and you just type like Mama.js, and you can see, okay, this file is like 2 megabytes or 20, I'm just exaggerating, but you can see how big it is if you check the non-gzip version part of the stats. So just use this tool and like kick away all those big libraries that you probably have. I promise those are the only GIF you will find here. So another important tool is called technique. It's called code splitting. It's pretty much taking parts of your application that you know are not going to be used right away, all of them, and splitting them in a way that makes sense. The easiest way is to split by routes. So the page code, the products page should be like one file of JavaScript. The account page should be another file. Because what is, if you're having users that haven't paid for a product yet, they don't have an account, why are you shipping them the code for the account, for all the things that they can do there if they're not gonna use it yet? And you're just making the experience slower and making it even harder for them to turn into potential customers. So that's the simplest approach, is by using splitting by routes. And for that, React provides something called React Suspense. And it kind of works like this. For example, let's say we have the product list that we had before. If we export all of our pages like this, we will have like the big chunk of file that I showed you before. This is actually taken from the Next.js version. Next.js will automatically do this for you, but I want to explain you how you would do it if you're probably using React Create App or something like that. So you start by importing React, and you can see that the import is going to change from a normal import to this thing. This is called dynamic imports. It's like a function. And you pass this import to react.lazy, and then you get like a lazy loaded version of product list. You cannot actually use it like this. So the next thing is that you wrap in React Suspense this thing product list, and then you just export it. So the last step will be we import, for example, a fallback, a loader, and once if you go to this route, it's gonna show this loader instead of the product list while it's fetching it from the server. Probably the sad thing is that React Suspense at this moment doesn't work with server-side rendering. You cannot use it on the backend, but there is a version that comes with Next.js that does exactly the same thing, just so you're aware that you'll be using like a custom version of Next. But this is like the general way to do it, and in the future, I hope in the upcoming months, this should be the only way to do it. So right now you can see each block is like a different page. So for example, you have the products page, the shopping cart, the account. Each one will be a separate block. And instead of having like a 10 megabytes on gzip app, you would just have to worry about like the common file that is shared across every page, and just the page that you're visiting. So if you go to another page, you already have the main library, and you will just download the little chunks that your users needed, and it's going to improve the experience a lot. So we're getting our performance a little bit higher. Now we can take this practice even further. There's something called intersection observer, which is like API provided by the browser that will let us know when the user is actually has some part of your HTML visible for example, he scroll to that position or he slide on a slider. So for example, let's say we have this whole home page here, and here there's this term called above the fold, which means the things that your user can see once he loads the application for the first time. He won't be able to see the bottom part because the application is scrolled on the beginning. And if you want, this is tricky because it really depends on the situation. You have to test if this makes sense. But you could do, for example, use React Suspense just on the bottom part. So if it is super critical that he has the JavaScript that it needs and you want to reduce it even further, you could use ship just the top part in the normal fashion, and the bottom will be asynchronous. So the part in yellow will actually load after the green part is loading. And if you don't want even to waste resources for the user, you can use intersection observer, which means that you will detect when the user scrolls to the position where you need this part, and then is when you will download it. But it really depends. Not every app will make sense for this. If your app is like not that long, then it doesn't make sense. If your app is like 10 pages long, then you could use something like this. And with Next.js, you can even server-side render this, like the whole thing, and just load the functionality for the green part and then load the functionality for the rest. And this way it will look that like the user have everything, but he cannot interact fully with the bottom part yet, which might not be that important. So just consider that the content above the fold, it's really important. So now we're doing pretty good. Have you ever heard about tree shaking? Some hands, okay. Kostya, yeah, you guys didn't come, yeah. So tree shaking is another technique that will help us reduce our file size. If you ever used Lodash before, you probably imported like this, import dash, that's why it's called Lodash, and then you use .omit and whatever function you need. The thing is that this Lodash, it includes every possible function that you're gonna use in a project, and even some that you haven't heard about it, but there are like, I don't know, hundreds of helpers there, and you maybe are using just a couple of those, or 3 or 4 or 5, but you're importing the whole library, and the whole library is like 500 kilobytes on gzip. So it's like quite huge, and you're like hurting yourself and your application by doing this. So what tree shaking allows is that you're just gonna use the functions that you care. You're gonna change how you import these things. So instead of importing the whole Lodash, you're gonna do this. The thing is that you cannot, for example, with Lodash, you cannot do this because Lodash is not written in ES6. There is a Lodash ES where you could do this, and Webpack will know, okay, you only want omit. It's gonna find the little code that is omit defined on Lodash, and that's the only thing it's gonna attach to your bundle, and that's it. So instead of 500 kilobytes, you have like 2 kilobytes. Or you could also import like directly like this, Lodash omit, and it will do the trick. Now, because Lodash is like a special case, you have to use a plugin that turns your code into from this into this, and then Webpack tree shaking can do its magic. This works for Randa, it works for Lodash, it works for Mamo.js and many libraries. So, but at least just be aware that there will be a plugin that will help you with the tree shaking. Just don't import things like this. Otherwise, tree shaking, there is no way for it to know what it should import or not. Now, another big performance hindering is the page trackers. Most of like production-ready websites have at least Google Analytics, but you might have Mixpanel and many others. And most of the time, like we are not aware how these things hurt our performance. If your application has like 4 trackers, then the browser will have to download all of them, process their JavaScript. Sometimes we get confused because we might think that, okay, this is the whole JavaScript thing that is gonna run for Google Analytics. But this is just the code that is gonna fetch Google Analytics. It's actually another big file, and the same thing is gonna happen with all of them. So what can we do? We need the analytics, so we should do something about it. But sometimes this is like a minify code, so it's usually unreadable. There is no way to figure out what's going on here. But if you pay close attention to it, you will start seeing some things. So for example, we can see here like that the yellow part is on this function is only responsible of adding the tag. It adds a script tag with a URL for Google Analytics /analytics.js. So it's gonna fetch the JavaScript. And the other part of the function is gonna be like a placeholder for the actual Google Analytics code. So a simplified version is kind of doing this. It adds GA to the window object, and it creates a function, and this function has a queue, and whatever you call something is gonna add a queue. Does everybody know what a queue is? Yeah, okay. Okay. In this case, it's just a simple array, and it's just gonna push whatever arguments that you pass. The arguments are usually the event name and all the rest. So what I want you to get from this is that Google is smart. They're already queuing whatever calls to Google Analytics you do with GA create, GA send, because they know when you call this, maybe the Google Analytics will not be downloaded yet. But the thing is that they don't expose a way for us to take advantage of this queue. So what we can do is create our own, like something like this. Is like a page tracker object with 2 methods. One is init and the other one is track. In init, we can pass like the amount of milliseconds we want to delay this tracker. And where it says tracker setup, we're gonna put the same code that was here. And on set timeout, that's where we're gonna put like the yellow part, so the part that actually adds the script tag and fetch the thing. And this way we can delay the execution of our trackers. And the track itself is just gonna check if it exists, it's gonna do the thing. If not, it's just gonna push it. And then we can, for example, we just called these trackers in the beginning of our code, and we just gonna defer them for 5 seconds, 8 seconds. We have to play with the number to see what makes sense. But this way, in the first 8 seconds of our app load, the user don't have to stop and wait for Google Analytics that will be blocking the actual interaction with the website. That's not the main goal for the user. The user doesn't care about analytics. So try to use this trick and explore a little bit. Obviously, each tracker is different, but this is like the main concept. And even if they don't have a queue, you could create like your own queue and have like a polling to check if the script is already loaded. If it's loaded, then dequeue all the items, and that'll be it. And it will improve your performance a lot. Like it could go from 40 points on Lighthouse to 88 easily if you have a lot of trackers that are affecting your performance. It really depends on your website, but that's something that you should care about. So just remember, try to defer them as much as possible. I know I say no more GIF, but this one looked good, and just remember, kick out all, defer everything to the end as much as possible. So now we got into the second part, which is the lifecycle performance, which means the performance of your app while after it already loaded. So React has this thing called the render tree. Render tree looks like this. We have some JSX on the right, and we have our application on the left. And the thing with the render tree is that it's going to work by rendering all the childs once it's being called. So if we check search here, if it's render, it's just going to affect itself. Slider, same thing. But if, for example, content renders, everything inside content, every component inside there will be called and will be re-rendered. So you can imagine if app renders, everything will re-render. So this is critical. This can kill your performance very easily if you're not aware that your application is being re-rendered, or this huge component is being re-rendered and rendering all the children's. So bear in mind that DOM manipulation is extremely expensive. It's the slowest part of the browser. Like pretty much everything else is like hundreds of times faster, but every time you touch the node, even just to read it, it's expensive. And changing classes, like it is gonna be horrendously expensive. So you want to avoid unnecessary re-renders. But the thing is that once you do this re-render, the truth is that this is not actually modifying the DOM, because React comes with a super system, like you probably heard about it, but it's called the virtual DOM, and it comes with this thing called diffing. Now, diffing is like the first line of defense on React to deal with this. So let's say we have a search input value component, and it's just going to be the white thing next to the go. And every time you render something, it's going to create some sort of abstraction. It should be an object like this that has like the type of the HTML element, the props, class name, value, children's. If you have many children's, it will be contained inside there. And the key and reference. So if you go to the search input and click and you type an R, let's say you're gonna search for React, it's gonna re-render, and it's gonna create like a new version of the render version that you had before, and it's gonna compare these two. It's gonna check, okay, I have value here, it was empty, now it's R, so because it changed, I should paint it. And then this painting is the DOM manipulation. But if it doesn't change, let's say it gets re-rendered, it checks this new version and it checks, okay, nothing changed, then it won't do the DOM manipulation. So it won't be that expensive. But the thing is that the diffing it's a little bit expensive, not as a DOM manipulation, but it will still have to check every property. It will have to check references, key. It will run a lot of life cycles, and it's like a huge rendering pad just to do this diffing. So if we can, we should avoid, we have to find a way to short circuit the diffing mechanism. So tell a component not to even render to not get to the diffing part. So the way to do it is with a life cycle. If we're talking about classes, it's called should component update. So let's say we have this search input here, and there is just a render method, but if we want to avoid to even go to the diffing part, we create this should component update. So it receives the next props, and you can compare, okay, the current props value, is it different than the one I'm gonna get? If it is not, if it is the same, then I should not render this, and you avoid all these diffing that will go if you don't have this. Now, there is, if you've seen it, there is React component and there is React pure component. React pure component already has this method by default, so you don't have to create it. So if you're using classes, you should probably always use React pure component instead of the component. And you might think it's a bit weird, like why is the more performant version of component like not the default? Why the default is like React component? Anybody has an idea? No? Danny? Okay. Yeah, the thing is, I think that React wanted to be child-proof with this. When you're, if your code has the should component update, and you're mutating the props in a parent, let's say you have an array. If you know the arrays will have the same reference, if you push elements into it, it won't change. It won't know there is a change because it will compare the previous array with the new array, and it will be the same. So you won't see any change, and probably developers that might not be that aware of this will get crazy trying to figure out why it's not changing. React pure component, it's more for people who probably are aware of this downsides of using it. If you're never mutating your data, you don't have to worry about it. But I think that's the main reason they do it. So we told you to convert all the classes to functions. So because there are no life cycles in functions, I'm not gonna tell you, hey, go back and create all classes now. So there is this thing called React Memo, which is a higher order component. It's just gonna wrap the function where you pass this search. So let's say we have this search input, and the only thing we do is wrap in React.memo. That's it. So this is the same as doing pure component. But should component update is more powerful because you can explicitly check what you want. But React Memo has you covered. You can pass a second function, and in this second function you're going to check the values, but it's going to be the opposite of should component update. It's not like it doesn't mean should component update. It's more like, is it equal? So if the response, if the return of this is equal, then it won't render. So if it returns true, it won't render. It's completely the opposite of should component update. Just be aware of that, or you might get crazy. So we're getting there. So let's talk a little bit about memory leaks. Memory leaks happens when you have references of objects that you haven't removed. JavaScript is a garbage collected language, which means that you normally don't need to clear your own the memory, but some things live in like the global space, so you need to be aware of those. So for example, let's say we have a component here called mouse chords, and we are using React useState. Here we have a handler that's gonna call our setState and assign some coordinates to it. So to do this, we use React useEffect, and this function is gonna run only once, and it's gonna because we have the second argument, which is the empty array there. With this, we make sure this listener only runs once. But what we're doing is adding an event listener to the global document, and then we're gonna return some HTML with the X and Y coordinates. This is all good, this is great. Does somebody see a bug here? Some hands? Just say you can. You don't have to prove it, don't worry. Okay. Yeah, everybody can see it. Okay. So the thing is that there's some global reference of listeners, and let's say these handlers are being kept somewhere by the browser. Like, let's say it's an array of all those functions that are for mouse move. And when you remove this mouse coords component, let's say it completely removed all the code from the memory except this handle mouse move, because it was never removed from this global reference. So right now you have like a zombie function. Actually, if you move the mouse, it will try to call set state. And here, because set state is in the upper scope, in the closure, it will also have state access to it, and it's gonna run into an error. But sometimes it's not obvious. Sometimes you're just adding code and creating things inside the functions, and just your memory is gonna keep growing and growing, and you're never gonna figure out what's wrong. So when React introduced hooks, they thought about this because this is something that people tend to forget. Before with classes, you have to call component will on mount and do all the clearing there. But because they were like so far apart in big classes, it was easy to forget. So here it's a bit simpler. You just return a function from the use effect, and this function is gonna be called and it's gonna clean up whatever you need to be cleaned up. So this is the only thing that you need to worry about it. This works for, you need to do this for event listeners, but also for timeouts, stuff like that. You have to keep the ID of the timeout and clear it here, and any other stuff that you can think of. But it's usually listeners and timeouts. So once you remove the listener, it's gonna remove it from the global reference, and you won't have this zombie function hanging there. So I guess it's time for the demo. So we're gonna cover a little bit of Chrome tools here, and so let's see. So the first tip I'm gonna give you is when you're testing performance, try to create a separate, if you're testing with Chrome, try to create like a separate user. You can create like multiple users in Chrome, like I have here Lighthouse, Lou, STRB, because probably the other one you're using for yourself, and you have like a lot of plugins that will mess with it. Each of these extensions normally add some JavaScript to your code, and you might be seeing like some extra code that is not related to your application, and it's going to be hard to figure out it's coming from there. So let's take a look. So the first thing, it's quite easy. We're just going to go to the apparently it's not that easy. Oh, yeah. I'm blind, yeah. So remember I mentioned the Lighthouse thing? This thing is built in here. So you just run audits here, and it's gonna check for some stuff, because we don't care about this other stuff. Maybe we can just check performance, and we can here change if it's gonna be simulated, 3G, or we're gonna leave it as it is. It's usually better to slow down the test, otherwise you might think, oh, everything's good, but yeah, it's not looking good for your users. So just run this. Right now it's gonna give us for a really bad score, because I have dev version, but you'll see. Yeah, so it's gonna show you some stuff here, like, yeah, it's empty for a while. You can solve this issue with the server-side rendering caching to have like a faster server response. And it's gonna give you a lot of things like, hey, minify your JavaScript, defer off-screen images, which is like not show things that are below the fold. This is related to what I mentioned with the intersection observer and React Suspense. So it's gonna give you a lot of tips. You can check this and play with this and see what Google recommends, and you'll probably have a good tip here and there. And yeah, just use it, change something and then run it again to see if it actually changed. There is also a service that is for Lighthouse that you could use on the browser instead of local. Sometimes it's good to do it because you have to be aware that you might be using resources with other things, and they might mess up with your task results because maybe sometimes it's using your memory or your CPU, and you test different times and you see, oh, it's improving, but no, maybe you just close Spotify and now it's like you're getting better results for this. It shouldn't matter that much, but it could happen. So sometimes you could use just the Google servers version. Just put but your app will have to be on production. You'll put your website and it will run the test. I would recommend that if you're using a domain, check the IP of the service. For example, if you're using Heroku, get the actual Heroku domain instead of the domain, because where the domain is and where the test is run might differ, and there might be some DNS resolution messing up with your test if you're only caring about performance. So try to test against that directly. And yeah, there are like many tips that you could check here, and you can spend your whole life trying to fix all of this. Don't obsess with getting like 100%. It's like probably not gonna happen, but just take it to a reasonable level. So what else we can check here? So we could, you should install this React tool, and you could see some things like, for example, you can highlight the updates of every time you're changing something. It's going to show you what is being re-rendered. So for example, if we go to sign up and we write, you see that when we write in one of these things is gonna re-render the whole thing. So we could try to fix this by going, for example, to our component. I think it's input, and here we have this, and right now, like, this function is being called every time we type anything. And this is a bit tricky to optimize. So this is just like an example for you to give you an idea. Sometimes we have to extract the whole thing. Like if we use React Memo here, it will not work because, yeah, these things are not changing. So it's all good. But the things that are changing are actually here in the render method. So we could technically use React Memo here, but it's better to extract it. So we could use like we could move all this thing here. And could use it. We need to pass, I think, something. Wait, I did it wrong. This is the thing that we want to extract. I probably won't do the whole thing, but I just want to like a console log here, render, and this thing, I'm just gonna pass some handlers, the data that is here, so like errors. And I'm missing some stuff. Yeah, here we have to call name, label, etc. And this is just like you will have to extract some parts, and this is where you will want to use React Memo. And once you add all this, you will realize that it actually doesn't work either. And you'll be like, why? I just added React Memo, like it should work. But the thing is that sometimes when we're just checking, like let's say just the value or just the name, like in this case, this one will work. But if we're passing objects to our components, JavaScript or React Memo will compare like object 1 to object 2, and even if they have like exactly the same things inside, this will fail because this is not equal in JavaScript. To compare this, you will need to iterate over each both objects and check each property, and then you will check if they match in structure, not in reference. So for just to keep in mind, because we don't have that much time, just to keep in mind, when you're checking this type of stuff, you always need to do the props and the next props, and check the values that you care. For example, fill, I think it is. Yeah, we're spreading fill here, and fill has on change, on blur, and value. But we don't care about on change or on blur. They will always be the same. So we can check only if props fill value change, and the same thing for the new prop. And you have to, it's not like straightforward when you're passing objects to your component. It's just so you're aware of all these things. I'm just gonna revert to all of this, but be aware of passing objects to child components. So always test that what you're doing works as you expect. Just don't add a React Memo to everything and you think, oh, okay, I'm covered, I have everything done, there's no need to do anything else because it's not gonna be there. There's also another tool called Profiler here. You could just start here recording and you start writing, and yeah, just perform some actions here, and you'll be able to see where your time is spent in different components, and you can see like how long it took for them, which properties it had, and it's used for overall. So it would take me a long time to literally explain everything, but just try to figure out based on the width of and the timings here, and figure out if there is a component causing you trouble. There is also, you could do it directly with Chrome, like not related to React. And the cool thing about this other one is that you could get extra information about paints. So you could have like, here in the bottom, you could see, okay, we just spent 981 seconds scripting, some rendering, some painting. And with this, when you're like doing some extreme performance optimizations, you can check what is causing like bottlenecks and all this stuff. And let's see what else. Another thing, especially good for time to interactive, is that you can also track your network activity, and you could change the speed that you're testing. Try to always test with a fast 3G to see if your app it doesn't break that much in slow connections. So that's something that you want to use. And yeah, ultimately this one it's good, but let me see, show console driver. This one's very faster. You could check this performance monitor, and for example, try navigating between your pages. It's gonna be a bit slow because it's dev mode, but let's try just switching between these two pages, and you're gonna see that memory is increasing, and it's gonna kind of increase for a while. This is kind of normal, like because garbage collection is not something that the browser wants to do like every second, because it's gonna freeze your application for a while. So only when it feels okay, I'm gonna freeze some resources, it should decrease this value. But if it's going up forever, like you see it get down, but if it's going down forever and ever, then it means you have a memory leak. So this is like a quick, easy trick to figure out that you have a memory leaks in your apps. Like it was 180, now it's 144, that's good. But if it gets to 800, like 500 and it keeps growing, okay, pay attention because there's something wrong over there. And you could, if you want to be like more exact, you could take a snapshot and do the same thing, like change between things. You will create like 2 snapshots and then compare the 2. This is gonna take forever. So, but yeah, you will create like 2 snapshots, and then there are some options here where you can compare what is the difference between the 2, and you can see what are the objects that are being held in memory after the change. This is like when you really have like performance issues that you need to worry about. Normally you wouldn't care about this, but in some extreme cases it's something to have in mind. And probably the last one I wanted to cover is I already mentioned the code splitting thing, but yeah, there's this thing called coverage. If this page was not built with Next, if we will call coverage, we will probably see a lot of JavaScript that is not being used on this whole application, and you will see, oh, okay, there is my account, there is my card, there is like a lot of things that I'm not using here, and this will help you to figure out how can you split a little bit more your application, because Next is already splitting this. There's not a big deal here, but it's also another tool you could use. And yeah, I guess let's go back here. So just wrapping up, just think about the TTI. It's really important for your users. It's been proven, as I mentioned, that it will turn into conversions. And even if it doesn't turn into conversions, just be nice to your users. Reduce the amount of JavaScript you serve. Don't let the trackers drag you down. Use React Memo, but as I say, be smart about it, because it's not just adding React Memo and it's magic. You need to be smart about it. And always try to rely on tests and tools to make your optimizations. Don't just go and make changes because you don't know if it actually gonna do what you think it's doing. So first check on the current state and then test after you make changes. And lastly, the last advice I will give you is try to emulate as I did with a slow connection, or like you can even slow your CPU, the CPU on Chrome DevTools. But if you can get like a real old Android phone or whatever and test it there, because if some users are gonna access your application via this, then you need to take care of this and actually see how it looks, because there is just so much that can be done with emulation, and it's good to actually have some real devices to see what you're doing is actually benefiting somebody. There's some photo reading here. There is this trick, debounce and throttle. They will help you to, for example, where you have a search bar and you're typing the search information, and you don't want to trigger like network calls on each one. You could, like with debounce, you could wait for the user to make a pause. This is usually when they stop typing, and that's when you start fetching your stuff. And throttle is to like limit the amount of executions a function will have. But it's actually a big topic, so you will have to read about it. There are some other hooks that React provides for performance optimizations. One of them is React callback, added the React Memo. And there is another one that I just had it there, so just you don't get confused if you find it. React Memo is a higher order component. React Use Memo is a hook. They are completely different. They serve different purposes, but both are pretty good. And the lastly is Reselect, which will help you when you're using Redux, because as I mentioned with the render tree, if you have connected elements to the store, every time something changes on Redux will trigger a change, which will in turn trigger a re-render, and in turn will like trigger all these performance things. So the more components you have connected, the more likely this will happen. But Reselect might help you a lot, along with some smart way of adding connect to your components. And that's it, guys. Any questions? Sure.
All what you said, is it for HTTP 1.1 or is it the same for HTTP 2?
Most of the things are irrelevant to HTTP protocol. The only things that will be relevant, for those who don't know, HTTP 1 is limits to 6 resources downloaded at the same time. While HTTP, you're not limited by this, so you can download many stuff at the same time and it will be faster. But the thing is that what I mentioned with files, even if you're downloading, let's say you have your app split in many components and you have like hundreds of Google Analytics and all this stuff, it doesn't matter how fast they download. The thing is that the JavaScript engine will still have to process the JavaScript. So HTTP 2 won't help you with this case because you will still wait some milliseconds. It could be 50, 100, 200, depending how much extra code you have. But yeah, it's not a matter how fast you can get this into your app. It's a matter of not processing this until you actually need it. So I hope that answers. Sure. Just as many as you want.
Where to use TypeScript and where to use JavaScript? Because I saw that TypeScript is slightly slower than JavaScript because it should be compiled first.
Okay, it's probably a misconception. You compile in your local machine, and this basically you have your TypeScript application, and then Webpack or Babel will convert everything to JavaScript, then your browser will just use JavaScript. So there is no way to run TypeScript directly on the browser. So it will be just as fast as regular JavaScript.
So that will cut so then everywhere using TypeScript, right?
Yeah, you can use TypeScript for everything. That's a different problem. It's more like a long learning curve or something, but not about performance. There are some things that is not super important, but TypeScript will create some, especially if you're using like class based approach, it will create some helpers to extend and all this stuff, and they might be repeated among different parts, and there are like some plugins to reduce this. This also applies actually for Babel when you're using classes and all this stuff. But besides that, it's just as fast as normal JavaScript. Any other question?
I have a question. How often do you do the optimization? It's like you finish the project and then you check the performance and the stuff. Do you have some benchmark or something?
Yeah, usually you just worry about doing your application, the business logic, you don't worry about it. But as I mentioned, there are things you can do in advance, like maybe server-side rendering, like maybe adding React Memo to the components that you think don't need extra tweaking. And maybe okay, I'm gonna have a page tracker. I could go from the start and do the trick for page trackers. But like extreme performance optimizations, you'll probably have to, I will do it after like the project is solid enough. Then I will run Lighthouse, see, okay, this is how I'm doing. It's okay, but I still need to add 200 features, so maybe I won't worry about it yet. So it really depends, but definitely not in the first stage of your development. You need to have something solid to test, because if you're gonna change everything in the next month, then you did some early optimization, and that's usually a waste of time, and is not recommended to do early optimizations. Just things that make sense on the long term. It doesn't matter when. So, anybody else? No, silent. Nobody cares about performance. Who cares? Okay.